Hello children, welcome to Akshara IT Foundation. Myself, I am Shivashankar, I am a physics teacher. So, in the previous class, we have discussed about the vectors chapter. So, all the concepts were completed. So, now today we are going to see the next basic chapter in the physics, that is the kinematics. So, we know that kinematics is a branch of mechanics, okay. So, mechanics is a branch of physics in which we are discussing, study about the motion of the objects there. So, that objects may be in the rest or in the motion. So, then what is the cause of the motion? These are all three, in the 3 point of view we can study the motion of the body there, okay. So, now here today we are going to see in the mechanics, a branch of physics is called the kinematics that we are going to study there. Now, the kinematics is nothing but a branch of physics which studies or which deals with the objects in motion, okay, which causes. So, what is the cause of the motion? We are not going to discuss here. We are going to discuss about the motion of the object there. Okay, that is called the kinematics. So, to understand the motion of the object, we need to understand some of the basic points. So, that we are going to discuss now. So, to study the motion of the object, we have to take a certain reference point. No? So, that reference point is called the, we can see the origin or the reference frame. Let us consider there means the reference frame is nothing but a background where the object is studied there. Object is analyzed or described. So, that is called the reference point. So, by using that reference point, we are going to be study the motion of the object there, okay. So, first of all, we will see the what is the motion at the rest, okay. So, in lower classes, we have studied about the motion and rest. Then sometimes this motion at the rest will become, motion will become a rest and rest will become motion. It will be appear like that whenever the objects are observed by the observer, okay, based on the reference frame from where we are observing. So, based on that it can be changed there, okay. So, now that type of quantities are known as relative quantities. So, now we will see there once again I will recall there what we have studied in the lower classes, the definitions of the rest and motion there, okay. So, motion is nothing but the position of the body which changes with respect to the time about the surroundings there. Suppose this body is there here, this body is there here, with respect to the surroundings here, with respect to the walls, the body is there here. After a certain time, it has changes its position there with respect to the time and the surroundings there. So, like that, if the body changes its position with respect to the time about the surroundings, then it is said to be the motion. The body is in the motion. We can say the body is in the motion there. Okay, that is called the motion. And the rest, if the body is there here, it does not changes its position, even the time goes. Okay. So, and the surroundings also with respect to the surroundings, the position is not changing. So, then we can say that body is at rest there. Like in our daily life, we can see many objects always they are in the rest and some objects always will be in the motion there. So, the rest is nothing but the object which is which does not change its position, then it is said to be the rest, and motion is nothing but the object will changes the position with respect to the time about its surroundings is called the motion there, okay. So, now this it will be changes, rest and motion will be changes according to the reference frame. So, reference frame is nothing but it is a background, as I said earlier, no, that is a background where the object is observed by the observer, okay. So, if the reference frame is changes, then rest and the motion will be changes there, rest will become a motion, motion will become rest, it will be observed by the observer, okay. Based on the reference frame it will be changes there. Like this quantities are known as relative physical relative quantities, okay, relative quantities. Now, some of the physical quantities will be present there. So, that physical quantities they does not change according to the reference frame. For example, we can take here the mass. Mass cannot be changes by changing the reference frame. So, from wherever you observe, it will be constant there, okay. So, then like this, there are some physical quantities are there, they are the absolute physical quantities, okay. So, next term we are going to see the few of the definitions which are very, very important to understand the motion of the object that we are going to see now here. So, our topic is today, that is the kinematics. Kinematics. So, kinematics is the branch of physics which studies the motion of the objects without cause of it. What causes the motion we are not going to discuss here. We will be see here what is the, we will be study the motion of the object there. Okay. So, now we will see here some important definitions. We will see there, the first one is a path. What is the path? So, path is a ways. Generally, if any object is moving from one position to other position, we can say there is a motion. So, whenever it is changes its position there, it crosses many positions there. It changes. It will be changes there many positions there. Okay. So, that positions, if you join that all the positions, suppose let us see here a body started from point a position A to position B, and then it went to position C. Finally, it has stopped at position D there here. Okay. So, now if all the positions are joined, okay, by a line, so then now we will be get a way. We will get a way there. So, this way is nothing but the path. So, how can you define it? So, we can define now like this: the line joining the successive positions of an object in which it has travelled there. So, that is called the path. So, path is nothing but it is the line joining the successive positions of an object in which it has travelled there is called the path. Okay. Now, here we can say the path is equals to, we can write here A, B, C, D is the path in which the body has travelled. Okay. So, then next definition is important is distance. So, next one is distance there. So, what is the distance then? So, if you measure here this total path travelled by the body, so that will be gives the distance, how much distance it has travelled there. So, total length of this path is said to be the distance there. Suppose here let us consider here A to B, from position A to position B, it may be 2 meters, or from B to C it may be 5 meters, C to D it may be 6 meters. Then the body has travelled how much distance from A to D there. Okay. To know that we have to add this all the positions, a small position from A to B and B to C and C to D we should find out there, we should measure there, and if you sum up all of them of the positions, then we will get a distance there. Okay. So, then the distance is nothing but the total length of the path, is said to be the distance there. Okay. So, here the distance can be written as, so the distance AD is equals to, we can write here AB plus BC plus CD. AD is equals to AB plus BC plus CD. So, now here AB it is a 2 meters plus BC is 5 meters and CD is a 6 meters. So, we will get here 13 meters distance it has travelled there. So, now we can say here the body has travelled 13 meters distance, that is the magnitude. This value will be the magnitude. The magnitude is nothing but what there, numerical value followed by its unit is called the magnitude there. Means certain value, certain numerical value will be get there. So, now the distance is nothing but total length of the path, path covered by the body or travelled by the body is called the distance, and this distance will be measured in meters. So, SI unit of distance is distance is meters, and the dimensional formula. So, dimensional formula is nothing but here meter will be the SI unit of distance, and that is nothing but the length. So, length will be the fundamental physical quantity. So, if any physical quantity is represented in the fundamental physical quantity, then that expression is called the dimensional formula. So, now dimensional formula of distance is L power 1, that is kept in the brackets there, L power 1, capital L. Okay. So now this distance is a scalar quantity. Distance is a scalar quantity. We know that uh, all the physical quantities are classified into two certain types. It is divided based on their direction and the magnitude. Okay, some of the physical quantities which have the both magnitude and direction, and some will be have only the magnitude. There is no direction there. So this distance is also such type there, where it has only the magnitude, no direction there. Why we cannot say here no direction? Because there are many directions involved there. We cannot specify a particular direction. Okay, so that we can say no direction. So then if there is no direction, only the magnitude, then we can say that is that physical quantity is said to be the scalar physical quantity. And this distance will be the always it is a positive value. Okay, if the body has not traveled, body is at rest means distance will be 0 there. In all the other cases, if the body is traveled, started its journey, then it will be have the distance there. Okay, so then this distance always it has a positive value. If a body is in the motion, then the distance will be present there. So the distance is always a positive value. Always a positive value will get there. Okay. Afterwards, after this distance, so next one more important definition is the displacement. Okay. So next one is displacement. Displacement. So what is the displacement? Displacement. Okay. See, to go from one place to other place, there are many ways will be present there. Okay. So then there are many ways means some ways will be lesser distance and some ways will be greater distance. Okay. But from a point, suppose let us consider here point A to B. To go point A to B, we have this is a one way, and this will be the other way, and this will be the other way there. So even we can go like this, even we can go like this there. These are all are the ways to go from A to B. Okay, to go from A to B, there are all the ways are there now. So in these all the ways, which is the shortest distance? Okay, shortest path. The shortest distance between the initial position and the final position is called the displacement there. Okay, to go in the shortest distance, definitely we have to specify a particular direction, no? So that this displacement will have both magnitude and the direction there. Okay, so displacement is nothing but the shortest distance. The shortest distance. The shortest distance between initial and final position. Initial and final position is called displacement. Displacement. Okay. So this displacement will be denoted by the letter here S or D. S or D. And it is a displacement. The displacement is a vector quantity, so it will be denoted by the letter S or D overheaded by an arrow. So it will be represent the vector quantity. This is a vector quantity. Here displacement will have both magnitude and the direction there. Okay. So now the SI unit of the displacement is SI unit of displacement is SI unit of displacement. SI unit of displacement is meters. SI unit of displacement is meters there. So dimension formula is same as the SI unit dimension formula is same as the distance. So here the dimension formula is same, that is L power 1 only, and this displacement will be the vector quantity. It is the vector quantity because it has both magnitude and direction there. So vector quantity, and this displacement will have, it may have the value, this value may be changes like 0, it may have the 0 and negative positive value also. So it may be negative comma positive and even 0 also. Okay. So this is the about the displacement. Displacement is nothing but the shortest distance between the initial and final position. Okay. So what are the differences between this distance and displacement? Okay. So displacement will be the shortest distance and distance will be the longer distance. Okay. Then always this displacement will be lesser or lesser than or equal to the distance. If the body is traveled in a straight line path, then distance will be equal to the displacement. But in all the cases, always this displacement will be lesser value than the distance there. Okay. If you take the ratio of displacement and the distance, okay, if you take the ratio of displacement to the distance, always it is greater than or equal to 1. Or if you take here the ratio of distance to the, sorry, displacement to the distance, the ratio of displacement to the distance, always it is lesser than or equal to 1, because the displacement is lesser than the distance, no? Then, so in the straight line path, the distance and displacement will be 0 there. So then we can take the ratio of displacement to the distance, always it is lesser than or equal to 1. If you take here distance by displacement, it will be always greater than or equal to 1. So these are the differences between the displacement and the distance. Okay. So next term we are going to see here. Speed. Okay. So next term is speed there. Speed. See, we listen this term frequently in our daily life. Speed. How much speed I have traveled by the bus or by the train, by the plane. Okay. Then speed will be denotes the motion. It will be explains about the motion, whether that motion of the body is faster or slower. Okay. So then speed is nothing but it is the ratio of distance traveled per unit time. Okay, distance traveled by a body per unit time is called the speed there. Simply we can say here distance, it is the ratio of the distance covered by the body to the time taken to cover the distance. Okay. So then the formula of and this speed can be denoted by V. Speed can be denoted by V. So that V is equals to distance is denoted by S or D. So here we can write their formula V is equals to S by T. V is equal to S by T. Then next here SI unit of the speed we can write here. SI unit of speed V is, so distance will be measured in meters and time will be measured in seconds there. So it is the ratio of distance to the time. Then we can write here meter per second or meter second inverse. Meter second inverse. Then the dimensional formula of distance. Sorry, dimensional formula of speed. Dimensional formula of speed. So here how we can get the dimensional formula? Always from the SI unit. So it is meter means L divided by time T. So divided by T. So means if you write in the numerator L T power minus 1. Okay. So L power 1 T power minus 1, or it also can be represented like this: M power 0 L power 1 T power minus 1. M power 0 value is 1 only, no? Because here a mass term is not there. Okay. So next one is next. This speed is a which quantity? Vector or scalar? It is a scalar quantity because it is a distance by time. So any distance by scalar divided by scalar. Time is also scalar, distance is also scalar. So we'll get a scalar value. Scalar is divided by the scalar, we'll get a scalar there. So now it is a speed is a scalar of physical quantity. Scalar physical quantity. So next one, this speed always, the speed is also here, speed always has a positive value. Speed always has a positive value there. It always have a positive value. Then CGS unit. See here the CGS unit, SI unit we have seen there. CGS unit of the speed. So in SI unit is meter per second there, CGS unit is centimeter per second. So CGS unit of speed is CGS unit of CGS unit of speed. CGS unit of speed is centimeter per second. Centimeter per second. Okay. So this is about the speed, and then next term, next definition we are going to see, that is the velocity. 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 So velocity is nothing but it is the ratio of displacement covered by a body per unit time is called the velocity there. Okay, ratio of displacement covered to the time taken to cover the displacement. So it's called the velocity. So then it can be denoted by the V bar because it is displacement by time. Displacement is a vector quantity. Then it is divided by that vector is divided by the scalar. We'll get a vector. So velocity vector will get here displacement by time there. So it also has the SI unit and the dimension formula same as the speed. But here this will be the vector quantity. Same as the speed, means meter per second. Meter per second, L T power minus 1 or the SI unit and dimension formula. Then it is a vector quantity. It is a vector quantity. Vector quantity. And this velocity has negative value, positive value, and even 0 also. Okay. Then CGS unit of velocity. CGS unit also it is same. So centimeter per second there. So now if you take the ratio of velocity, ratio of the velocity and the speed there. Okay. So if you take the ratio of velocity V bar to the speed V bar, so this is always lesser than or equal to 1. And if you take the ratio of speed divided by the velocity, ratio of speed to the velocity, here we can add that will be the greater than or equal to 1. Okay. This is about the speed and the velocity. And next one we have the change in velocity. Change in velocity there. Okay. Suppose a body is moving from whenever it is started from the rest, it will be have the 0 speed. Then if it is started and went onto the road, then the speed of the vehicle will be increases there. So that will be the whenever it is going to be stopped, then it will be just before going to be stopped there, it will attain a maximum velocity there. That is the final velocity. Whenever the body has started its motion, then the speed with what speed it is started, that is called the initial velocity there. Okay. So now the change in velocity is nothing but the difference of final velocity and the initial velocity. Difference in the final velocity and initial velocity. Okay. So now we'll see there change in velocity. Change in velocity. Change in velocity. So it is the difference of initial and final velocity. It is the difference of final and initial velocity. Final and initial velocity. Final and initial velocity is called change in velocity. So change in velocity, it is denoted by delta V. Change in velocity. So delta symbol, delta it represents the change. So that can be written as here, the final velocity is denoted by the V and the initial velocity is denoted by U there. So here V and U. So V will be the final velocity and U will be the initial velocity. U is initial velocity. Okay. So final velocity and initial velocity. If the final velocity of the body is greater than the initial velocity, then the change in velocity will give the positive value. And if the final velocity is lesser than the initial velocity, then we'll get the negative value. Change in velocity will be negative value. Means if a body is started from rest and it is the velocity will be increases, then to certain value there, maximum value will get a positive change in the velocity will get a positive value when the body is going to be stopped there. So then we'll get a negative value there, negative. The change in velocity will be negative. Okay. So this is called the change in velocity. Change in velocity also same units as a speed and velocity there. Dimension formula is also same, and this is also vector quantity, and okay, all the units and dimensions are same as the speed and velocity there. That is called the change in velocity. And next term we are going to see, that is an important one. It is the acceleration. Acceleration. So acceleration is nothing but the rate of change of velocity is called the acceleration. The rate of change of velocity. The rate of change of velocity. Rate of change of velocity is called acceleration. And it is denoted by the letter A. Okay. So now here a change in velocity. Rate is nothing but any physical quantity divided by the time. So what it is dividing here, change in velocity is dividing by the time. So that is called the acceleration. Then here A is equals to delta V divided by T will write there. So this is nothing but here V minus U by T will get here. So therefore A is equals to V minus U by T will be the formula or the expression for the acceleration here. Okay, expression for acceleration. So change in velocity per time there, then SI unit of this acceleration, SI unit of acceleration is, SI unit of acceleration is, here change in velocity is same. Now SI unit of velocity, that is meter per second divided by time again. Okay, so meter per second divided by time again. So meter per second square, meter by second square, or meter per second square, or meter second inverse 2. Meter second inverse 2. Then the dimensional formula of acceleration. Dimensional formula of acceleration. So dimensional formula always will get from the SI unit. SI unit is what? The meter per second square. Meter symbol is what here? Length, capital L, divided by second square. Second symbol is T, time, no, T. So power here 2 there. Okay. So if you write this all in the in numerator, so L T power minus 2 we can write, and is also equal to M power 0 L power 1 T power minus 2. So this will be the dimension formula of the acceleration. And this acceleration also it is a vector quantity, because the velocity will be the vector quantity. So velocity is dividing by the time there, then the vector, velocity is a vector divided by the scalar. So then we'll get a vector. Vector is divided by the scalar, will get a vector. So here the acceleration is a vector physical quantity. So it is a vector physical quantity. It is the vector physical quantity. Okay, no? So then acceleration also has, it may be the positive value, negative value, and 0 also. Okay. So then the CGS unit of this acceleration is centimeter per second square. Centimeter per second square. Okay. So this is about the acceleration. Then now we are going to see there. We have studied their speed and velocity. No, there are different types of speed and different types of velocities are there. So now we'll see the types of even the acceleration also. In acceleration also there are types of accelerations we'll see are there. We are going to see them. Okay. Now first one we'll see the types of speeds. Types of speeds. So first one is average speed. Average speed. Suppose a body is traveled longer distances. So in that whole distance, in whole journey, the body may be travel different distances in different time intervals. Okay. So then throughout the journey, To calculate the average speed, what we have to do there? We have to sum of all the distances in different time intervals. Then the total distance by the total time, if you take there, we'll get a average speed there. Okay, it can be defined as then the total distance covered by a body to the, it is a ratio of total distance covered by a body to the total time taken. It is called the average speed. Suppose the formula of this average speed can be given by V AVG average is equals to, suppose in d1 distance, in t1 time it may be travel the d1 distance, and t2 time it may travel d2 distance, like that. n in nth interval, in number of n intervals it may travel dn distance. Then we can write here the average speed is d1 plus d2 plus d3 plus so on up to here dn divided by t1 plus t2 plus t3 plus so on up to tn. So this is the basic formula of the average speed. Okay. So then next here this average speed will have the both same units as the speed and the velocity there, even the dimensional formula also, and the average speed also, it is a speed, average speed, it is a scalar quantity. Okay. So the next one we are going to see here average we are going to see here next type of speed, that is the instantaneous speed. Instantaneous speed there. Instantaneous speed. So instantaneous speed is nothing but the speed of a body. Speed of a body at a particular interval of time is called instantaneous speed. Okay. The speed of a body at a particular interval of time is called instantaneous speed. So that instantaneous speed can be given by the formula as, so ds by dt we can write here, that is equals to limit delta t tends to 0, delta s divided by delta t is the expression for the instantaneous speed. Okay. These are the some of the types, and we have one next one. Next speed. So third one is uniform speed. Uniform speed or uniform motion. Uniform speed. If a body is travel equal distances in equal interval of time there. Okay, when a body is traveling longer distances, then it may travel different distances in different interval of time. No? So then if it is travel, if the body will travel equal distances in equal interval of time, then we can say the body is moving with a uniform speed, means the speed of the body is constant there. Okay, so that speed is called uniform speed. Okay, so when a body covers equal distances in equal interval of time, is called the uniform speed. Okay. So now here we can represent like this. Suppose a body is travel from A to B and B to C and C to D. Okay. Suppose from A to B it is a 1 meter. It may take 1 second. Suppose let us consider here, and B to C is 1 meter, and it may take here 1 second, and B to C to D also 1 meter, and it may take in time is 1 second. So like that, in every interval of time it will be travel the same distance. Then we can say that motion of the body is called uniform motion or the uniform speed. Okay. So next one, the uniform speed also has the same units and dimension formula as the speed. The next one is the non-uniform speed. So non-uniform speed there. So it is the reverse of this. Whenever a body is traveling unequal distances in equal interval of time or equal distances in unequal interval of time there, then that motion is said to be the non-uniform speed there. We can say variable speed. The speed of the body may be, sometimes it will be increases and sometimes it may be decreases there. So that type of motion is called the non-uniform speed. Okay. So when a body covers unequal distances, unequal distances in equal interval of time, in equal interval of time, or equal distances in an equal interval of time. Is called the non-uniform motion. Is called non-uniform motion. Non-uniform motion. We can represent like this. Suppose a body is traveled from A to B. It is the 2 meters. It may have taken 2 seconds, and the next interval it may be taken here 3 meters. So in 2 seconds. So like C to D, it may have taken 4 meters in 2 seconds. Then afterwards, it may take here 1 meter. So like this. So unequal distances in equal interval of time. So then that motion of the object is said to be the non-uniform motion. So this is about the different types of the speeds. So next we are going to see the types of velocity. Okay, types of velocity. Types of velocity. So here also we have the same 4 types, like average velocity, and then next we have the instantaneous velocity, instantaneous velocity, and third one we have the uniform velocity, and fourth one is non-uniform velocity, non-uniform velocity. Okay. So average velocity is nothing but it can be the ratio of total distance traveled to the total time taken, and the instantaneous velocity is nothing but the velocity of a body at a particular interval of time is said to be the instantaneous velocity. And for this average velocity, so the formula can be given for the average velocity: VAB bar is equals to D1 bar plus D2 bar plus D3 bar plus so on up to here Dn bar divided by T1 plus T2 plus T3 plus so on up to here Tn we can write. And the next instantaneous velocity. Instantaneous velocity is nothing but the velocity of a body at a particular interval of time. So that instantaneous velocity can be given as here V insta is equals to, so we can write here ds bar by dt, and that is equals to delta limit delta t tends to 0 delta s bar by delta t. Delta s by delta t will take that. So this is the formula for the average speed and the average average velocity and the instantaneous velocity. And next uniform velocity. Uniform velocity is nothing but if a body covers equal displacements in equal interval of time, then it is said to be the uniform velocity. So means constant. If a body is moving with constant velocity, then we can say it is a uniform velocity. If with the variable velocity, if the body is moving with variable velocity, or we can say how it will be variable. If it is travel unequal distance in equal interval of time or equal distances in unequal interval of time, we will get the variable velocity. Then we can say the body that motion of the body or the velocity of the body is said to be the non-uniform velocity there. Okay. So this is about the types of velocities. And here if you take the ratio of average velocity VABG bar, always this average velocity is lesser than or equal to the average speed. And if you consider the ratio, if you take the ratio of average velocity to the average speed, we will get always it will be the lesser than or equal to 1. Or if you take the ratio of average speed to the average velocity, always it is greater than or equal to 1 there. And same SI unit and dimension formula is same as the average. Generally it is like a speed and velocity there. Okay. So now here in the average speed we have, there are different cases. That cases we'll see here. Different cases in the different cases in average speed. Average speed. Suppose if the body is traveled, first case we'll see here, first one. If a body is traveled between the A and B there, between A and B. It has a journey between A and B positions or A and B places. To travel A to B, if it is taken V1 speed, and from B to A, if it is taken here V2 speed, then we'll get a average speed of the body. Okay. So A to B, it is a particular distance will be there, total distance, let us consider that is D. Then average speed formula, what we can add here? Average speed formula we have said there, total distance by total time. Total distance by total time there. So to travel A to B, it will be take a time T1, and to travel again to return back to the A from B, it will be take the time T2. Then total distance by total time means we'll take here D divided by T1 plus T2 will take here T1 plus T2, no? T1 plus T2. Okay. So this will be D divided by T1. How can you write that? T1 value. If you substitute here T1 and T2, D is the here D distance. Certain distance is there. A total distance A to B and B to A means here D plus D will get, and T1. How can you write the T1 value? T1 is nothing but what there? So from the speed is speed definition, distance by time there. So then from T1, then from that definition we can write T1 is equal to distance by speed we can add. Then here we can add there D by V1 will get, and here D by V2. Okay. So from that if you take D common, here in the numerator it will become 2D divided by, if you take here D is common, no? D is a common letter between the V1, 1 by V1 plus 1 by V2 in the denominator. So now this D and D will be cancelled there. If we simplify that, we'll get this formula as 2 into V1 V2 divided by V1 plus V2. Okay, this is the first case. And even in this case, this formula will be applicable to travel half of the distance with a speed V1 and remaining half of the speed with the V2. So also in that case also, in the second case is what there, if a body is travel half of the distance with a certain speed and remaining half of the distance with a certain other speed, then means here we can take V1 speed and V2 speed. So in this case also we'll get the same formula, that is average speed is 2 into V1 V2 divided by V1 plus V2. Okay. These are two cases. And next one, suppose same formula will use that like this. Suppose if a body is travel first 1/3 of the distance with a speed of V1 and next 1/3 of the distance with a speed V2 and remaining distance with a speed of V3. Then, so what is the average speed there? So that is the third case we'll see here. If a body is cover certain total distance between A and B. Okay, so in this total distance, if it is covered 1/3 of the distance means D by 3, no? And that you consider here C, A to C, and C to D you consider it is here D by 3. Remaining distance is D by 3 only, no? Next, first D by 3 is with the speed V1 and next D by 3 is with speed V2 and last D by 3 is with the speed V3. So then the average speed between A and B. Okay. So average speed formula we can write same in the previous case how we have derived, in the same way we can derive here. So from A to B the total distance is, so the formula, basic formula is what there, total distance by total time. Total distance by total time. So now here total distance from A to B is D only, and the total time. So from A to C it will be take a time T1 and C to D it will be take a time T2, and from D to B it will be take time T3. So then total time we can write here T1 plus T2 plus T3. Okay. So then if you write here T1 value, T2 value, T3 value, how can I write there? In terms of density and the speed we can write, that is, so D divided by, so D divided by D whole divided by, T1 is nothing but D by V1 plus, so D by V2 plus D by V3 we get there. So from there in the denominator there is a D is a common term, we can take common and cancel with the numerator d. In the numerator also d is there. If you cancel there, we will get the value like this. So 1 by v1 plus 1 by v2 plus 1 by v3. Okay. So now if you simplify this one, what do you get here now? And so here actually it is d by 3, no? T1 will get there d by 3 means, so here we will get there d by 3 v1, d by 3 v2, d by 3 v3. So now here 1 by 3, 1 by d by 3 we should take common and dt will be gets cancelled there, 1 by 3 will be remain here still. Now this 3 will be go to the numerator. If you get to the numerator, then if you do the LCM here, what is the LCM will get here v1, v2, v3, v1, v2, v3. So now if that LCM has divided by the first denominator, we will get the v2 plus v2, v3 will get here v2, v3 plus with the, if the LCM is divided with the second denominator, we will get there v1, v3 plus, so here we will get there v1, v2, v1, v2. So then finally we will get the answer as, in this case the average speed is 3 into v1, v2, v3 divided by, so v1, v2 plus v1, v2 plus v2, v3 plus v3, v1. So this is the formula for the average speed of a body whenever it is covered first half of the distance with the speed v1, next first one third of the distance with the speed v1, next one third with the speed v2, and the last one third with the speed v3. If the speeds are given, we can find out the average speed like this for any distance. Okay, suppose if the value is given in percentages, how can we write there? Okay, so first x percentage of the distance with the speed v1 and next remaining percentage, it is given with a certain speed v2. Then in that case, what is the formula will get there? So that we'll see that. So with that, if you know that, we can write for any ratios, we can find out there. So there, last case, if a body is covers from A to B, if it is travel certain distance, then this total distance from A to B, the first x percentage of the distance with the speed of v1 and remaining distance, remaining is how much it will become then? There is a d minus x, no? Remaining distance will be d minus x percentage, d minus x percentage. It is travel with a speed v2. Then here the time from x percentage of the distance can be travel. It will be take a time. The time can be written as here d by. How can I write here? D into x percentage means d by x d by 100 will get, that is the total distance. It will be travel with a speed v1. Next t2 time here we can write there. So that is the d minus x percentage of the total distance. Means here we can write here d minus x, d minus here x by 100 into d. Okay, x percentage and remaining distance here it is the, suppose it is x percentage and d minus x percentage. So then we'll get here like this. Next one. So average speed, V average. So V average is equals to total distance is what here? Total distance by total time. Total distance by total time. So total distance is what here? Total distance is d, and total time is t1 plus t2. T1 plus t2. T1 plus t2. No? So then here what can we write here? Average speed is equals to d divided by so t1 is nothing but how much you get there? xd divided by so 100 into v1 we can write plus and remaining percentage. So that is that here we can write there, that is a d minus. So here d minus x divided by 100 into d by v2. Okay. If we simplify, we will get the value. So like this, in the same way we have to simplify. We will get here 100 into v1 v2 divided by 100 into v1 v2 divided by here x percentage, no? So instead of taking here d minus x, we can write here 100 minus x percentage. In the 100% we are taking, no? Here we can write it as instead of this one d minus x, here we can write like 100 minus x percentage, 100 minus x percentage, the remaining percentage. Okay, 100 minus x percentage. So here also we can write, this one is 100, we can write 100 minus x percentage. So it will become 100 minus x, no, divided by 100 into d there. So in the last here also we'll get here, that is 100 minus x. So this is 100 minus x divided by 100 into d. So here we'll get there 100 minus x, 100 minus x into 100 minus x into, so we'll write here v1 plus x into v2. So by using this formula we can write for any distance, okay, any part of the distance, it is traveling with a speed, and remaining speed with remaining distance with a speed with v2, then we can find out by using this formula there. Okay, so this is about the different cases in the average speed and average velocity. In average velocity, so we have a one more formula, that is the in terms of if a body is moving with the initial velocity and the final velocity. In terms of average velocity, in terms of the velocity, the average velocity formula is given by this average velocity. Average velocity. Average velocity in terms of velocities of a body there, initial velocity and final velocity. So it is the average of the initial and final velocity. Then we can write here VAVG bar is equals to, it is the u plus v by 2. If the body has initial velocity and the final velocity, so not only in terms of always the displacement, it is not only in terms of displacement, it may be in terms of velocity also they may ask, then it is the formula there. Average velocity is average of initial and final velocities. Whenever we can use this formula, whenever the initial velocity and the final velocity of the body is given there. Okay, so that is about the initial velocity and the, up to here we have learned the speed and types of the speeds and velocities and different cases in the average speed and formula, different another formula of the average velocity. Okay, so next one we are going to see here types of the average types of the accelerations. Okay, you see that types of acceleration. Types of acceleration. So we know that acceleration is nothing but the rate of change of velocity. Okay, so here first acceleration, we can write here positive acceleration. Okay, positive acceleration. So positive acceleration nothing but the acceleration of a body whenever the speed increases. If the speed increases, then the final velocity will be greater than the initial velocity, so that the acceleration will get a positive value. So that velocity, that acceleration is called the positive acceleration. Okay, when the velocity of a body is increases, the final velocity of a body is increases with respect to the time, or the velocity of the body is increases with respect to the time, then we will get the body will have the acceleration, that acceleration is called the positive acceleration there. When the velocity of the body is decreases, means a body, the motion of the body started from the rest. Okay, from the rest it is started, then the body will have the positive acceleration. So we can say the body is moving with the acceleration. So that motion of the body is said to be the accelerated motion. If the body is going to be stopped, then the speed, the acceleration will be decreased, means velocity will be decreases. So we'll get a negative acceleration. So that acceleration is also called as deceleration or retardation. Okay, so negative. Next one is negative acceleration. Negative acceleration. So if the velocity of the body is decreases, then that acceleration is said to be the negative acceleration, or it is also said to be the deceleration or the retardation. Deceleration or retardation. Retardation or deceleration is nothing but negative of acceleration. Negative acceleration is called the deceleration or retardation. Okay. So this is next one. So uniform acceleration or non-uniform acceleration or constant acceleration. Okay, uniform acceleration. If a body is moving with constant acceleration, then that acceleration of the body is said to be the uniform acceleration. And non-uniform acceleration means the body is changing its, the acceleration of body changes. Okay, in its journey, then we can say that acceleration of the body is said to be the non-uniform accelerations. Okay, third one is here. Third one is uniform acceleration, and non-uniform acceleration is the fourth one, and last one is the instantaneous acceleration. Okay, so fifth one is instantaneous acceleration. Instantaneous acceleration, the acceleration of body at a particular instant of time. Instantaneous acceleration. So instantaneous acceleration formula can be given by A insta is equals to dv bar by dt, or we can write here limit delta t tends to 0. Here we can write there dv by dt. This is the instantaneous acceleration. Expression for the instantaneous acceleration. This is the different types of the accelerations. Okay. So next one, to study the motion of the object. So there are different types of the equations are there. So that equations are known as equations of motion. So equations of motion is nothing but the expressions or the equations which will be gives the relation between the physical quantities of a motion of an object there. So we have come across here most of the physical quantities like speed, distance, displacement, time, acceleration. So between these, there is a relation between these, all the physical quantities will be exist. By that relations, we can understand the motion of the object there. So the equations which can represent or which gives the relation between the physical quantities, different physical quantities of the motion of the object, then they are said to be the equations of motion. So there are 4 equations of motion there. We are going to see them. Equations of motion. Equations of motion there. Okay, first equation of motion. There are 4 equations of motion are there. So first equation we will get it from the definition of the acceleration. That is nothing but here v is equals to u plus at. This will be the, from the definition of the acceleration we will get there. So we know that a is equals to v minus u by t now. So if you cross multiply t to the acceleration, and from that we will get there v is equals to final velocity is equals to initial velocity plus acceleration into time we will get. And second one is s is equals to ut plus half at square. S is equals to ut plus half at square. And third one we have the v square minus u square is equals to 2as. V square minus u square is equal to as. And fourth one we have Sn is equals to u plus a into n minus half, or it is also equal to u plus so a by 2, u plus a by 2 into so 2n minus half. So these are the 4 equations of motion. Here this is the relation between, first equation of motion will give the relation between the initial velocity, final velocity and acceleration at the time. And the second equation of motion will be given by the relation between the distance or the displacement, velocity at the time and the acceleration. And the third equation of motion will be given the relation between the initial velocity, final velocity, acceleration at the distance there or the displacement. And fourth one will be given the difference between the fourth one and here fifth one, this second one. Okay, this is also equation of the displacement, this is also equation of the displacement. But here the second one is what there, the displacement traveled by a body in certain time interval. In certain time interval, the expression for the displacement will be given by this equation. S is equal to ut plus half at square. It is the displacement or the distance traveled in particular time interval. And here in the fourth one, it is also distance or displacement traveled by the body in a particular time interval. In a particular time interval. This is in the time interval. In a particular time interval means, that means it may be the 1 second, the distance traveled by the body in the 1 second, or in the second or in the third second, like that. So second equation that will be gives the displacement of a body in 10 second or in 5 second or in 2 seconds, like that. In the In certain duration of time, the distance traveled by the body will be given by the equation is s is equal to ut plus half a t square in a particular interval of time It may be 1 second, 2 second, nth second, okay, or 3 seconds, like that, in a particular interval of time. So the equation will be given by Sn is equal to u plus a into n minus half, or u plus a by 2 into 2n minus half. That is the three equations of motion, four equations of motion. By using that equations of motion, we get to know the whole study of the motion can be done, understand easily. Okay, next one is motion under the gravity. So up to here we have discussed motion in a straight line. The body is moving in a motion in a straight line. Even this topic also motion in a straight line, but is not along the x-axis. It is along the y-axis there. Okay, or we can say vertical motion. So motion under the gravity. So under the gravity, how the motion of the object can be taken place. So there are two cases are here. The motion under gravity, motion under gravity. Okay. So here we are going to discuss this motion under gravity in two cases. That is, first one is free fall, freely falling of a body there. Freely falling of a body. Freely falling of a body. Freely falling of a body. And second one is vertically projected body. Vertically projected body. Vertically projected body. Vertically projected body. So here vertically, freely falling means a body is dropped from certain height. If a body is dropped from certain height, then the motion of the object can be described or studied by the equations which we have seen there. By those equations only we are going to study them. Then vertically projected body. If a body is thrown vertically upwards, then what is the motion of the body? So this here, that all the four equations can be changed by using this here. So here, if a freely falling body, u is equal to 0 and acceleration of the body is acceleration due to gravity. We can write here. And this one, first equation of motion can be written as here v is equals to g into t, and second equation of motion can be written as here s is equals to half into gt square, and here third equation of motion can be written as here v square is equals to 2gh, because u is 0 there here, and fourth equation of motion can be written as here hn is equals to u will be not there here, u is 0, so then here g into n minus half. So these are the four equations can be replaced, four equations can be written like this, that all the four equations can be written like that. And in the vertically projected body, first equation of motion can be written as here v is equals to u minus gt. Here it is, the initial velocity, it will be have certain initial velocity v, here u, and the acceleration will be minus g. We can write here minus g. Minus means, so here the speed of the body is moving. If the body is projected vertically upward, the speed of the body will be decreases, and finally it will be get a 0. Then again it will be come down there. Okay. So the speed will be decreases, then acceleration of the body is said to be the negative, deceleration or retardation. No. So that is the reason why here we will use there minus g. Then next one, second equation of motion can be written as here h is equals to ut minus half gt square, ut minus half gt square, and third equation of motion can be here, it is written as v square minus u square is equals to minus 2gh. Okay, and fourth equation of motion can be written as hn is equals to u minus g into n minus half. That is by using these four equations of motion, we are going to discuss. We can understand the motion of the body there. Okay. So here, whenever the body is thrown vertically upward, or whenever the body is thrown vertically downward there, so means if a body is falling freely there, so it will be take certain time there, from maximum height, time taken by a body to reach the ground, or the time taken by a body. There are the time will be taken there. We are going to discuss here time of ascent and time of descent and maximum height. Okay. So now in the projected case, we are going to discuss about the maximum height there. So maximum height of a body. So maximum height is nothing but whenever the body is projected vertically upwards, so the height where its final velocity will become 0. Okay, that height is called, that height reached by the body is called the maximum height. So at the maximum height, the final velocity will become 0 and a is equals to minus g, we can write there. By using the third equation of motion, v square minus u square is equals to minus 2gh, no, in the case of projected vertically upward body. So then here we can write there v is 0, here we can write this is a 0 whole square minus u square is equals to minus 2gh. This will be the h maximum. Okay, from that we will get here minus u square is equals to minus 2g h maximum, minus 2g h maximum, minus minus will be cancelled there. So from this h maximum is equals to, we will get the formula u square by 2g, u square by 2g. So in the last class, in the last this formula will be used to find out the maximum height of the body. H maximum is equals to u square by 2g. Okay, and here we are going to discuss about the time of ascent also. If it is projected vertical upwards, so it will be take a certain time to reach the maximum height there. So that time is called the time of ascent. It can be denoted by the t suffix a. So the formula for that is u by g there. So how can I find out? By using the first equation of motion, by using this one. Okay, at maximum height this velocity will become 0 and this is a u and minus gta. Then from this we can write here ta is equal to, what can we write here, minus u by minus gt, no, minus g. Okay, minus and minus will be cancelled, therefore ta is equal to, time of ascent will be, time of ascent is equals to, we can write here u by g, u by g. So like that we will get the time of descent, the time taken by a body to reach the ground from the maximum height. So that formula also will get there same. So that is denoted by Td, that is also will get the same value, that is u by z. So this time of ascent is equals to time of descent. So both it will be both time of ascent and time of descent will be equal. Ta is equals to, we can write here Td. Okay. So then now the total time of flight. So the body, whenever a body is thrown vertically upward, it will be reaches to the maximum height and from by there it will be fall down there. Whenever the body is in the air, so then the time taken by a body which will be stay in the air is called the time of flight, or total sum of the time of ascent and time of descent is called the time of flight. That can be denoted by the capital T. It is nothing but Ta plus Td, Ta plus Td. So then if you write here Ta is equals to, if you write these two values here, we will get there 2u by g, 2u by g. So this is called the time of flight formula. Okay. So next we have the horizontal projection also. In the horizontal projection is nothing but if a body is projected from certain height. Horizontal projection, horizontal projection. If a body is projected horizontally from certain height. So like let us take here, it is, this is the tower. From here any body is projected horizontally, then this body will be go and fall at certain distance from this bottom of the tower there. So this is called the horizontal range, and this is a u here. Okay, it will be reach the ground. Before it is reaching there, it will be have the final velocity v. Okay, always at any point this horizontal velocity will be constant there at any point there. Okay, so that is the u, it will be there, or we can say horizontal velocity. Now we can add here u. Okay, u x also we can add there. And vertical component of velocity, suppose if you take here, this is a theta and this will be initial velocity. So this also can be taken as here u cos theta. So that will be discussed in the case of a projectile. Now we will take only here u as, we will take u, and here this one. So vertical component of velocity here, so that is u by. Okay, here uy will be 0, vertical component of velocity will be 0 at this maximum height there. So then it will be take time to reach the ground. So that is it is nothing but the Td, no, time of descent, T suffix d. So that formula will get the expression there. So from where we'll get there, that is by using the second equation of motion, we'll get here square root of 2h by g will get, this is the time of descent formula there. Time taken by the body to reach the ground whenever it is projected with certain velocity u horizontally from the top of the tower or top of certain height there. And now here we'll take there, and it will be reaches with certain speed, no, that is called 2gh. From the third equation of motion we'll get there. This is from second equation of motion there. And now the horizontal range, it can be written as here u into t, time of flight. So time of flight is called there Td only, no, Td. Td will be the time of flight here. So e into square root of 2h by g. So this is the a body projected certain velocity from the top of tower. That is called the horizontal projection of an object there. Horizontal projection. Okay. So this is all about the motion in a straight line. Motion in a straight line there. Then next we are going to see here motion in a plane. Afterwards we have the graphs of motion also. So we'll see there graphs of motion. Then we'll see there next projectile motion. Okay. So graphs of motion. Next one. After this we have the graphs of motion. So graphs of motion. Graphs of motion. So graphs of motion we can write here. So graphical representation of a motion of an object. So graph is a very important. By seeing the diagram, so we are getting know about the all the information about the motion of the object there. So okay. So it is a diagrammatical representation of a motion of an object is said to be the graphical graphs of motion of an object. So there are three types of graphs we have there. So ST graph. ST graph is nothing but the position time graph, and second one we have the VT graph. So VT graph is nothing but the velocity time graph, and third one we have the acceleration time graph there. Acceleration time graph. Okay. So again in this each and every graph there. So what is the ST graph? ST graph is nothing but position time graph. Position time graph. This will be the position time graph. Position time graph. Okay, and this is the velocity time graph there. Velocity time graph. Velocity time graph. And this one is the acceleration time graph there. Acceleration time graph. That means here position is taken on the y-axis and time is taken on the x-axis there. So we said when we have started this chapter, no, we have said there some reference point, no. So the reference point will be considered by using this Cartesian coordinate system. So the origin will be the intersection of x-axis and y-axis is nothing but the origin, no, that is called the reference point it has considered there. Then if the on the y-axis if the displacement or the distance is taken, or we can represent that with s also, it is taken and the time is taken on the x-axis, then that is called the distance time graph, and velocity is taken on the y-axis and the time is taken on the here x-axis, then it can be said as the velocity time graph, and acceleration is taken on the y-axis there and the time is taken on the x-axis, that can be said to be the acceleration time graph there. So there are different cases in the ST graph and VT graph and AT graph. Okay. So here in AT graph, if a body is at rest there. Okay. So now we'll see there in the first one. So first ST graph will see there. Different cases in the ST graph there. The first case what? If a body is at rest there. If a body is at rest, then the graph will be the graph has a straight line which is parallel to the x-axis. This is displacement and this will be the time there. Displacement and the time. And the second case we have if a body is moving with the uniform motion. This is a displacement time graph. Uniform motion means velocity displacement will be constant, means velocity will be constant. Here what the slope? Here the slope will be 0, v is 0 here, and here v is a constant. V will be the constant. V is nothing but what there? Slope. That is nothing but y coordinate to the ratio of y coordinate to the x coordinate. Okay. And next, if a body is moving with increasing velocity means we'll get a curve like this. If a body is moving with increasing velocity there. Okay. This is a displacement and here the time. So v is increases. Slope is increases there. Increases. And next, third case we have if it is moving with decreasing speed there. Then this is a displacement and time graph. Here the v is decreases. V will be decreases. Okay. So these are all the cases about the displacement of time graph. And next we have the cases in the second one, that is a VT graph. In the VT graph we have the different cases there. So VT graph we can see here. In the VT graph also, if the body is at rest there, if the body is at rest, then here we'll get there. This is a parallel to the x-axis. So on the x-axis, on the y-axis, it is velocity is taken. On the x-axis, time will be taken here. The graph is at the straight line. The graph is parallel to the x-axis. We can say the body is at rest there. Okay. So body is at rest means here we can say a is equal to 0. A is equal to 0, and v is constant at certain time there. And if it is moving with the uniform acceleration, we'll get a straight line. Okay, and on the y-axis we'll take here v, and on time it is taken on the x-axis. We'll get a straight line which is passing through the origin. So here the acceleration is what there? Acceleration is constant here. Acceleration is constant. Means it is moving with constant acceleration. So here in the previous class, case we have seen now equations of motion. So that the equations of all the motions will be valid here in this case only when the body is moving with constant acceleration. Okay, then that case only we can write all the equations of motion there. So next third one, here we can say here if the body is moving with increasing acceleration, we'll get like this. And fourth one will be if the body is moving with a decreasing acceleration, we'll get like this. Or we can say non-uniform acceleration. Okay, so these are the graphs of motion, and final one is there, that is the acceleration time graph. In the acceleration time graph, acceleration will be taken on the y-axis and the time is taken on the x-axis. Okay, then there also we have the if the body acceleration has 0, then the graph is along the x-axis, and acceleration of the body is constant, then the graph will be the parallel to the x-axis. Here the acceleration of the body will be the constant there. And if it is moving with uniform acceleration, the acceleration time graph will be the straight line which is passing through the origin there. If it is non-uniform, then we'll get the variable acceleration. We can say that is a variable acceleration. So like that, we have the acceleration. These are all the graphs of motion. Okay. So then we have the last topic is there, that is motion in a plane. We'll see in the next class. Okay. Thank you, children. Have a nice day.